Alright, so today Academic Daddy will be teaching you everything you need to know on mixtures. So, first of all, mixtures. Now, you need to know that when we talk about mixtures, we are simply talking about uh, the coming together or rubbing together, joining together of substituents, constituents by physical means. So whenever you combine or you mix up materials by physical means, which means that it can be uh, separated by physical means as well. That means separating it will be easy. Or should I say, when you take vigorous process, you are sure that you must get separation. So under these mixtures, we have two types of mixtures you need to know. And one is what we call the homogeneous mixture. The other one is what we call the heterogeneous mixtures. So these are the two types. Now, when you hear homogeneous, it means that this, or you can say that homogeneous mixtures are mixtures in one phase. They are mixtures in one phase. So when the mixture is in one phase, you say it's a homogeneous mixture. So mixtures in one phase, that means they are combined together, that when you're looking at it, you cannot see separation, you cannot see difference. For example, air that we breathe is finely mixed oxygen and inside nitrogen. So they are mixed finely. For example, when you have sugar inside water, it mixed finely. So when you have a mixture that is properly mixed, you say it's homogeneous mixture. So under this we have uh, what we call solution, and under this we also have what we call alloy for metals. Now, heterogeneous mixtures are mixtures in two phase. Heterogeneous mixtures are mixtures in two phase. Mixtures in two phase are called heterogeneous mixtures. So when the mixture noticeably is such that the constituents are not mixed finely, it has different phase. You can look at it and notice, for example, when you mix sand and water, you notice that it does not mix very well. When you mix stone and sand, so it's always existing in a state of maybe liquid, solid, gas. It doesn't mix very well. But you need to know that all gas mixtures are solutions. They fall under these all gas mixtures. So for that reason, we have under these things like colloids, colloids that is under this, and we also have things like colloids, and we also have things like suspension. So these are the types of mixtures we have. Now, what are the examples we have? So a situation where I have this, to get the difference, for you to remember it, always use what I call s square nad. S square nad. Now s square means 2s, that is particle settlement, or particle settlement, how the particles settle, particle size. Now this one stands for nature. This one stands for nature of the particle. This one stands for appearance of the particle. And this one stands for diffusion of the particle. So if you know this, it simply means that when I have these mixtures, For me to characterize it or to differentiate it, I must make use of these subtitles. These are the categories that these mixtures fall in, that you can get the difference. So for solution, a situation where I have a solution and I have a colloid and I have a suspension. So to get the difference between these, all I need to do is, first of all, the particle settling. So when it has to do with settlement, sorry, this one does not settle. Solutions does not settle. So a solution does not settle. Then for colloids, now you need to know example of solution. A typical example of solution is sugar. Typical example of a solution is sugar plus water when it's not saturated. So a typical example of colloid is things like oil plus water. Typical example of suspension is things like sand plus water. So for colloids, they don't settle, does not settle, but when you start doing the separation, using separation technique, things like centrifugation, it will not settle. They don't settle, but they separate into layers. So you see it when you pour oil inside water. At a point, it will take over, then it will not separate, but it does not settle naturally. It's during centrifugation, during separation technique, that you now have it settle. Now for suspension settles. They settle. When you pour sand inside water, it will go and occupy that bottom. It settles. Suspension settle. Now for size, we normally say that this is below 10 cubic nanometer, and this one is between 10 cubic nanometer, and this one is equal to 10 cubic nanometer. Now for nature of the particle, the nature of a solution is that it is homogeneous. So this is 1, 2, 3, 4, and 5. So I've gotten 1, gotten 2, 3. Now for colloids, they are heterogeneous in nature. Now for appearance, you need to know that whenever they are asking you about appearance, what they have in mind is what is the ratio, like should I say, is it transparent, is it opaque? Transparent means can you see through it, opaque means you can't see through it, or is it translucent? Translucent means semi-transparent, you can slightly see through it. So for solutions are transparent. If you pour sugar inside water, you can see through that water. Colloids can be said to be translucent, because as you are seeing that oil on top of that water, if you look somehow, you can see the bottom of the water, but not very well. Translucent. Why suspension, notice that it will go and block. If you pour enough sand in that water, it will block the visibility, you will not see anything, so it is opaque. So for diffusion, because this one is in one phase, they say the lighter you are, the faster you can be. This is Graham's law of diffusion. So when you know this, which says that the rate of diffusion is inversely proportional to the square root of the molar masses of the gas. So if you know this, it simply means that since this one is in one phase, it will have rapid diffusion. Now since this one is a bit translucent and settles on top of the water slightly, it will diffuse, it will have slow diffusion, it will have slow diffusion. Why suspension, there's nothing to diffuse there, it will not diffuse. Even if it diffuse, it will be very very slow diffusion, so it does not diffuse. So there you have it, there you have it. Today I want to believe I've been able to teach you the uh, types of mixtures. And to conclude this, to conclude this to conclude this, I'ma need you to know, I'ma need you to know what's the difference between solution, solute and solvent is. So when you hear solution, note it that solution is a homogeneous mixture containing solutes and solvents finely mixed together, or you say it is a homogeneous mixture in one phase. So this is equals to mathematically solute plus solvent. Now solute, the substance being dissolved is called a solute. For example, sugar and water, sugar is the solute. So the substance that gets dissolved is called solute. Substance that gets dissolved is called solute. That gets dissolved. Substance that gets dissolved is called solute. While solvent is the substance, water and sugar, between water and sugar, water is the solvent. So the substance doing the dissolving, the substance doing the dissolving, or the substance that dissolves the solute. So the substance doing the dissolving is known as a solvent. And you need to know that this solvent, the solvent is always in a larger quantity, is always in a large quantity when compared to the solute, so that it can be able to dissolve it. So there you have it. In our next class I'll be teaching you about what's it called, standard solution. Any solution that you know the concentration is said to be a standard solution. Thank you very much. Academic Daddy, please like, subscribe and share.